Okay, so wait a couple seconds. We should be on. Section 2.3, deductive reasoning. Okay, there's a lot of words on this page. It's kind of like an English lesson again, but it's not too terribly hard. Okay, we went over the other day something called inductive reasoning, where we were talking about patterns. Do you guys remember that pattern lesson where it said something like, this is like your movie show times are at 1:30, at 12, at blah, blah, blah. You have to find a pattern of what's happening next. Okay, deductive reasoning is where they give you a conclusion and you have to try to draw patterns from that. Okay, so they give you kind of like the broad general conclusion and you have to pull stuff out of that. Okay, inductive reasoning means you're putting patterns together in something to make a conclusion. Deductive reasoning means you're taking it apart. So you're taking a conclusion and you're pulling it down. Okay, so example 1, determine whether each conclusion is inductive or deductive. Let's go through one more thing. Inductive uses patterns or observations to make a conjecture. Deductive reasoning uses facts, rules, definitions, or properties to reach a logical conclusion, okay, from given statements. All right, determine whether each is inductive or deductive. We're going to use an I or a D. Every time Lauren has a healthy meal before her run, she is able to run farther than her sister who does not like to eat healthy foods. Lauren has eaten a healthy meal, so she concludes that she will run farther than her sister. Now, is that based more on patterns or is that based on facts? So it's going to be a fact that she is definitely going to run farther than her sister.
Yes. No.
I think it's more based on a pattern. In the past, it has done this, right? I'm going to guess that it's going to do that again, but it's not going to be actual factual information until after the race is over, right? Actual factual. So that's going to be inductive reasoning because it's based on a pattern. I'm going to say equals pattern because it's the pattern that she is running faster than her sister when she eats a healthy meal. If John is late making his car insurance payments, he will be assessed a late fee of $50. John's payment is late this month, so he concludes that he will be assessed a late fee of $50. Fact or pattern? Fact. There's no ifs, ands, or buts about it. That is deductive reasoning. I am taking the facts and I am drawing conclusions from the facts. No longer patterns. Okay? Are you girls still with us? Are we still doing okay? Oh boy, they gone. See?
No, I'm still here.
No, they're still here. Oh my gosh, this is so exciting. Woo! Okay, they were just muted. It'd take her a while to unmute. Okay, got it. Okay. This is so exciting. So exciting. We'll see if the video records. Now we'll log off and the video will say, nope, you can't save it or whatever.
I feel like
okay.
you won't be able to hear it.
I don't know. All right, so 2 more things. Number 1 is the law of detachment, and the other one is the law of syllogism. Okay? That's kind of a crazy word, but the law of detachment first. This thing has a pattern to it, and it's drawing conclusions from this pattern. So what they will give to you is they will give you P, then Q. They will tell you something is going to happen if something else happens. They will also give you the next P, and then you have to draw the conclusion of Q. So this is U. You have to figure out what Q means. So this is very easy. Here's what you're given. If 2 angles are a linear pair, that's P. Then their non-common sides are opposite rays. That's Q. Okay, so let's talk about what this means. If 2 angles are a linear pair, what does it mean to be a linear pair?
Don't touch.
Nope, they do touch. They do touch. They add it to 180. Like this angle, angle 1, and angle 2, those are a linear pair because they live on this straight line. That's a linear pair. Okay? Then their non-common sides are opposite rays. The non-common sides are this one and this one. Are those opposite each other? Mm-hmm. You betcha. They're going opposite directions. Then their non-common sides are opposite rays. That's P and then Q. If this happens, then this happens. Mm-hmm. Then it says AED and AEB form a linear pair. That is saying P again, right? We're just restating it, but now with the angles that are attached. So the conclusion is that those 2 sides are opposite rays. This is like saying what Q says. Does that make sense? That's my conclusion. Okay, so we're giving names to these. This is A, E, D. Oh, wait a second. I switched those around. A goes here. AED and AEB. So this says the ED and EB are opposite rays. That's my conclusion Q. Okay, good. Let's go to this one. B. If Micah goes to the beach, that's P. She will wear sunscreen. That's Q. Now, Micah is wearing sunscreen. Wait a second. What is that? That's Q. Does that necessarily mean that she's at the beach? No, this is invalid.
So this one you don't know.
Okay, this one is valid. This one is invalid. Determine whether each conclusion, I didn't read the directions. Determine whether each conclusion is valid or invalid. Okay, based on the given information. So the first one is valid because it does go in the order of P, Q, P, Q. The second one is not valid because it goes P, Q, Q, P. I do not necessarily know. I know that if she goes to the beach, she's wearing sunscreen. But I do not know that if she's wearing sunscreen, she's necessarily going to the beach. It doesn't go the other way around, right? Because she could be at the park. She could be at the pool. She could be somewhere else, right? If she's wearing sunscreen. I don't necessarily know that. So this one is invalid. Does that make sense?
Okay, how did you figure that out again? Okay.
Okay, law of detachment must go in the order of P, Q, P, Q. P, then Q, P, then Q, where this is the overall conclusion. Okay? All right? P, Q, P, Q. Good? Yes? All right, so let's do our own. Determine whether each conclusion is valid or invalid based on the given information. If a primate is an ape, that is P. Then it does not have a tail. That is Q. Coco is a primate who does not have a tail. That is
All of it.
all of it. That's P and Q.
So
Coco is an ape. Oh, wait, that's the second part's really only Q, I guess. It's really only
so
Q.
it's invalid.
Then this part is P, so do I necessarily know that it goes in reverse? I know that if P is Q, then true is Q. I know that this happens. If P is Q, then true is Q. But I do not necessarily know that the reverse happens. So Q and then P does not work, so this is invalid. Okay? If Coco is a primate who does not have a tail, does he have to be an ape?
No.
What could he be instead?
A dog.
He's a primate that doesn't have a
A
tail.
monkey.
A monkey has a tail.
Gorilla.
A baboon, right? Is that a primate?
I have no idea.
A gorilla.
Okay. Does a baboon have a tail?
No.
I think a chimpanzee, does that have a tail?
A baboon.
A baboon doesn't have a tail? Okay.
Their butts are little.
Because their butts are real pink and they look sore.
So cheeked up on
Okay,
it.
so that one is invalid. I'm not going to worry about the explain your reasoning using a Venn diagram because that's really complicated, okay? But I'm going to go ahead and put a counter example. Counter example that proves that false. This could be a, what did we say, baboon? I don't know if baboons have tails. Do baboons have tails? No. We're going to assume that they don't because they have sore butts. Okay, counter example, a baboon. That is an invalid statement.
We have to put a counter example.
They do not ask that. Baboons have tails? They're what? Is it a long tail?
Yeah.
Oh. Well, then we can't use that.
How am I supposed to know?
What's another primate that doesn't have a tail? It's a chimpanzee.
It is a Barbary.
Chimps don't have tails?
Barbary,
Chimp.
Max. See if the chimpanzees have tails. I don't see Casey. Yeah.
I don't know if I
Have tails.
spelled that right. Chimpanzee. He doesn't have a tail.
No, they don't.
Yay! There we go. There's our counter example.
Wait, so
Okay.
do we have to do that? Baboons don't.
No, this one did not ask for a counter example, but I'm just kind of planting that seed in your head that we know why it's invalid.
On the
Okay?
homework it says explain your reasoning.
That's a counter.
Then that's a counter example, I guess.
So just like
So, explain your reasoning. There we go. A counter example chimpanzee does not
I know. I tried.
makes that invalid. Okay? The second one, law of syllogism, says if P is true, then Q is true. If Q is true, then R is true. But that means that if P is true, then R is also true. Okay? All right, so this is also, listen guys, this is also kind of like the transitive property which we've had before. The transitive property which says I'm going to say Casey and Maya, are you the same age? How old are you?
15.
17.
Casey, same age as Maya. You're both 15. Who else is 15?
Me.
Maya, same age as, same age as Kira. Okay, so let's pick out our P's and Q's. Who is P? Casey is P. Who is Q? Maya is Q. Maya is also Q again down here. Kira is R. So P implies Q. Q implies R. So our conclusion is that Casey is same age as Kira. Right?
Yeah.
Because P is the same age as Kira. Okay, well, we're going by just like year instead of date. Okay? So Casey is the same age as Kira. That is P and then R. That's the transitive property. Okay? P implies Q. Q implies R. P implies R. Okay? All right, here we go. Determine whether each statement is valid or invalid given the information. If not, write invalid. Explain your reasoning. Okay, let's break this guy down. This is what they give to us. This is given. Number 1, if you are an actor, that is P. Then you enjoy musicals. That is Q. We're assuming that's a true statement. If you are an actor, then you enjoy musicals. If you enjoy musicals, that is Q again. Then you enjoy theater productions. That is R. Okay? So what should our conclusion be?
If you're an actor, then you enjoy theater.
If you are an actor, then you enjoy theater productions, which is part B. So this is valid. Okay, let's see why this one is not valid. If you enjoy musicals, then you are an actor. If you enjoy musicals is Q, then you are an actor. That is P. So we know that if you're an actor, you automatically enjoy musicals. That's just the way that it works. But if you enjoy musicals, do you have to be an actor? I kind of enjoy musicals, but I'm not an actress, right? Okay, so counterexample. Mrs. K, I enjoy musicals, right? You guys like musicals too. You guys have seen musicals on TV.
No,
Like
I've
every
never
Disney
watched
movie
it.
there ever is a musical, basically, because it has music in it. Okay. Maybe you don't, but Maya does, right, Maya?
I don't like
Okay. So counterexample, Mrs. K, or anybody anywhere who is a musical lover that's not an actor. Okay. That is my counterexample. Okay. Good. All right, last thing. Apply some deductive reasoning. Draw a valid conclusion from the given statements if possible. So, let me break this down before we get our conclusion. The law of detachment.
Wait, B, did you put valid?
And the law, B is valid. And the law of syllogism.
I thought we said it was invalid.
Okay?
No. Wait.
Here's how these two break down. The law of detachment, here's what they will give to you. They will give you P implies Q, and P implies something, and you come up with the Q part. This is what you need to find. Okay? For the law of syllogism, they give you P then Q, Q then R, and you have to come up with P then R, right? This is the part that you need to find. That is your conclusion. So each one of these pieces that are in purple are the conclusion. Make sense? Those are my conclusion pieces. Okay? So let's go up here and let's figure out whether this is the law of detachment or law of syllogism and then come up with our conclusion. Draw a valid conclusion from the given statements if possible. Given. If you are 16 years old, that is P. Then you can apply for a driver's license. That is Q. Nate is 16 years old. That is P. So are we looking at detachment or syllogism? Detachment. What's our conclusion?
So you can get your driver's license.
Who?
You can get your driver's license.
Nate can get his driver's license. Nate can apply for a driver's license because that is the Q part of it. Does that make sense? Nate can apply for a driver's license. This is the Q part. That's our conclusion. So we have concluded PQ and PQ. We have done the whole thing PQ, PQ. Okay? So kind of just look at the pieces that you're given. It would be a good idea to label them PQ, PQ, but don't write in your book. Okay? Is that it? That's it. How was that?
It seems quite useless to know.
It does seem quite weird. Okay?
Hey,
The basis of doing this is basically they don't want you to draw any conclusions that you're not allowed to. Like, I am not allowed to put words in somebody else's mouth. I am not allowed to conclude up here that what's her bucket went to the beach if she's wearing sunscreen. The other way around is true. If she's at the beach, she's wearing sunscreen, but I don't know if she's wearing sunscreen, she's at the beach. So it's trying to prevent you from drawing conclusions that are not there. Okay? Homework's up here at the top. How are you girls doing?
Good.
Good? How was that?
Mhm.
Yeah? Are you laying in bed taking a nap while we're doing notes?
Honestly, that's the way to go.
Really?
All right, I'm gonna quit recording and see if it's saved.
what do you want me to do with this? It's for
Maybe.
Friday. It's the homework for Friday.
Movie recording. How do I stop recording?